Hey, how's it going? This is Tim here. This is going to be your first lab for lockdown Mech 110. Um, so let's write. I'm going to write some stuff down. So what are we going to do? So this is Mech 110 Lab 1, and what are we going to do? Our objectives. We're going to number one. We're going to connect our DC motor to the power supply. That's number one. Number two, we're going to measure the speed of the DC motor. Number three, we're going to plot a curve of voltage versus motor speed. And what else? That's it. That's our first lab. Now, first thing, I want you to dig out of your equipment box a couple of things. This is your tachometer, and I'm after throwing out the box that mine was in, but don't worry, it was in a nice little packet. Don't throw it out though, keep it all together. This is the shiny flash tape that comes with the tachometer, and in the back you have a little we have a little Phillips screw. Please, I'm pretty sure I gave everyone a very small screw. You're going to be able to open this up, okay? So we'll talk about that in a second. So you're going to need the tachometer. You're going to have to get your screwdrivers out. You're going to need some of this flashy tape. That's number one. You're going to have your little multimeter. You're going to have to open this up. Where is it? How do I open it up? Let me check. It might actually be that screw right there, but we can talk about that later. Yeah. I'll open that up now in a sec just to go over it again. Here's your little multimeter, and you have little cute probes. We have that. What else do you need? In your one of the Ziploc bags, there should be a little power supply. Notice that you can adjust the power supply there. And in that little kit is a little connector that I'm just adjusting right now that looks like this. Okay, and what you can do is you can put in different type of connectors onto the end of this, but this is our AC to DC power split. I'm going to talk about that later. You're going to need to dig that out. You're also going to have to dig out one of these motors. Okay, now if you're unlucky enough to get a motor that has connectors on it, what you're going to do is you're going to use, hold on a sec. I'm pretty sure, come on you stupid thing, here we go. You're going to need a little Pittsburgh wrench, and what you can do is if there's connectors on this little plastic things, you can cut them off, and then what I like to do is you're going to have to get rid of that little wire. What you can do is you can just very carefully, look, I even use my teeth for something like this. Let me show you. Or you can use wire strippers. Now watch. You're just trying to get rid of the plastic. Alright, the other thing you can do is you can use this, even though these are snips, you can grab onto it and you don't cut all the way in and you drag it off, and you should be able to if you're having trouble with that, during the lab that I'm available, I'm going to show you a lot of different ways. Look, I'm assuming you all know how to do that, but you might not. I can't assume that. Alright, what else? That's the first thing. Alright, so let's talk about the first thing is let's get this bad boy going. You're going to flip it around, and there's a little screw there. You're gonna open this up. Now, I'm making this video earlier for people that if they want to go ahead or they want to see if they want to work on this stuff. This thing isn't even plugged in. What the hell? Interesting. Now, do I have a battery that goes with this? I thought I was messing around with this already. A 9-volt battery. Alright, now hopefully you've changed these batteries out because you know, you have a smoke alarm in your house. But anyway, alright, there's your 9-volt battery. What's nice about this is it has these terminals already on it, so watch. You see that? And then you're going to push it in. And let's see, can we feed this in like so. Jam it back in there like this. And get your, try not to lose the Phillips screw. Put your cover back on. Get your little screwdriver. Now I'm pretty sure I included every little size screwdriver with your kits. If you're having major trouble, you can also buy a little set of screwdrivers in McMaster-Carr, any store. Alright, now let's see, does it turn on? Happy days. Okay, now I'm going to put the probes in. Right, I have a red probe and I have a black probe. See these covers here? Get rid of them, or you can chew on them if you want, but don't chew anything else. I'm putting them in the trash. Now, the black goes into this COM, and the red, it doesn't go into this 10 amp, it goes into this one, the voltage, like so. In most configurations, it's going to be black here and red here like that. I have 2 probes. This is called a multimeter. The reason why it's called a multimeter is it can measure voltage, it can measure current, it can measure resistance, it can measure, that's about it. Okay, now this can measure AC and it can measure DC. Now we need to talk about that. Okay. AC is a lot more dangerous than DC. AC stands for, now hopefully you're learning this in your electrical class. I'm teaching you mechanics, but I'm not going to assume it. AC stands for alternating current. DC stands for direct current. Now, I plug this into the wall, okay, and AC comes in here. This is essentially, they call this a transformer. It's a brick transformer, or they call it a power supply. Okay, what it does, it takes AC in here, and notice, I have, now, do I have a little flathead screwdriver anywhere? Hold your horses now. Hold your horses, I'm not going to use a knife. Or a coin or something would even work. It actually does come with, oh look at that. It does come with a little gizmo to change it. Am I dropping coke on the floor already? Hold on, hold on. Where is it? I'm just going to pause this for 1 sec. Now in your kit, mine isn't very organized, is a little key like that. Look at that. And the key goes in here and you can adjust that power supply. So if I say to you, I want 3 volts, you're going to adjust it to there. If I say, nah, we're going to crank this up and I want 6, you're going to adjust it to there. Magic. Now, keep him close or you're going to have to find a flathead screwdriver, which I know you have loads of. Alright. So, let's look at AC and DC for a second. An AC supply, it has a symbol like this, and if this is a flashlight, what's the symbol for a flashlight? Something like this. Now in the wall, the AC is 110, 115 volts. In the US, 220, 230, 240, I can't even remember, 240 in Ireland and everywhere else. Okay, so 110 volts. And what happens here is it alternates, goes off in this direction and flips back in this direction, flips back in this direction, and goes back and forth 60 times a second. So back and forth, and it alternates. That's just I know I can't get my head around it either, but that's how it works. And it goes back and forth. Direct current, if I get rid of this and I have a DC, and I have plus and negative, it just goes around the whole time continuously in the one direction. Now, the motor you're using, let's have a look. Does it say? It doesn't say anywhere what the voltage is supposed to be, but we'll find out that in a second. This is a Vex 2-wire motor 393. Now I know, where's my pencil after fall? I know that this is a DC motor, so we cannot provide AC power to it. It would blow the head off it. Now, so we plug this into the wall, and inside here it converts AC into DC using a transformer and a diode and stuff and all that magic. And what comes in the output? AC 110 goes in here, DC whatever we selected here comes out. Now let's see, does it actually say? We can actually read this and see what it says. It says input AC 100 to 240 volts, and it can actually output, it can deal with both types of voltage. Now, you could use this multimeter to measure the voltage of the wall of the AC. Let me just show you. This first one is DC voltage. You can see by the symbol. That's when you want to measure DC voltage. This is when you want to measure AC voltage. Now, you could go to the wall and plug these in. If you touch anywhere near those probes when you're measuring the wall, you are going to get a shock, and it's going to be sore, and you know, if you're the chances of it killing you in the United States are low enough, but don't go doing it. It's sore and it shocks, and you might be unlucky that it might catch you in such a way that it goes through your heart and kills you. So don't measure AC. Just trust me. But we can measure DC to our heart's content, and we will. That's AC voltage. That's measuring resistance. When we're going to measure current next week, we're going to go over here. Wherever it says A, that's amperes, which is the unit for current. We'll talk about that later. V is the unit for volts. So anyway, so that's how this works. We'll go back to this in a second. He's set up. Now, we have two terminals. We have a positive and we have a negative. Hopefully you have a little screwdriver. So we're going to double check this. That's the first thing we're going to do. So now can I jam these in here side by side? We'll find out. So first thing we're going to do is we're going to open up each of these screws. And I'm going to put the red in at the positive, feed it in like so, and I'm going to screw down on top of it. Just nice and easy. I'm going to take the black one, feed that in there, and screw down. Now let me tell you a new word. The new word is an electrical short. If I plug this in, which I am, I'm going to plug it into the, you can't really see this. Do I have a plug here? Shut up, Ollie. Shh, oi, calm down. Shh. Alright, I have this plugged in into the wall, so there is DC power coming out here. I'm going to turn this on. Now, I wish this thing had a background. I'm getting 6.45 volts. Okay, now basically 6.45 volts is coming out at this positive. It's zooming around the circuit, and the voltmeter, the multimeter is measuring it. If I take something that conducts electricity and I put it across both of those terminals, all the power from that multimeter, 3 amps of it, is going to jump from here to here. And I don't know if that power supply has a fuse on it, but it would be it's gonna scare you. It's gonna arc if you put something across here. So try not to short your 2 connections. Do you know what I'm saying? You do have electrical tape if you would prefer to tape, but you need to create a barrier between the 2 contacts. Does that make sense? Now I have only one power supply and I don't want to test it right now to see if it's going to blow that. Okay, but I do not want to short. I do not want to create an electrical connection between positive and negative. I could. Now what that does is look something like this. What that does is it creates a wire between here, and all the electrons want to just go nuts, and they will just travel all the way down through this. And what that do is what it does is it basically blows the head off that power supply. That power supply can't handle any of it. All right. What we can do is we can put something in series with the circuit, like a resistor or a motor or something, and current. It allows a control current to flow. Now, hopefully, you're getting that in you will be getting that in your electrical class. The instructor will explain that a lot better. So, what the hell am I trying to say to you? Don't let these 2 things connect. I know some of you probably will, and you probably blow up that power supply, and I'm probably gonna have to get another power supply to you. But try not to. All right? I've blown up more power supplies, so you wouldn't be the only one. Now let's look. The output of the voltmeter is 6.45. Now let's have a look at this power supply, and you can see that it's set at 6. I'm going to move this down to 3, and let's see what happens. Now I've unplugged this, and you can see here that the voltage is coming down. I'm guessing there's some sort of capacitor or something that's storing energy. Even though we've no energy, we have the power has been switched off. This machine still has some stored energy. That's why you've talked about lockout tagout. I'm going to plug it back in now. Now, took it a couple of seconds to catch up. So I'm getting 3.63 volts. Okay, so whatever the voltage says on the power supply, it's a little bit higher that it's kicking out. Let's unplug this again, and let's crank it up. What's nice about this is essentially an adjustable power supply. It says 12 volts. I'm going to plug it in. 12.63. Okay. Now, part of me wants to short this power supply out and see what happens. Um, at the very least, you're gonna damage the power supply if you do that. I don't know if there's a fuse or something in there that would protect it. If there is such a thing as a fuse, that's some sort of overload protection system. And then what we can do is we can go in and replace the fuse instead of destroying the whole power supply. Now, so that's look. Let's recap. We have our adjustable power supply. What I want you to do is I want you to be able to measure the first thing. I want you to be able to measure the voltage coming out of the power supply using the digital multimeter. That's the first thing that I need you to be able to do. Number one, the class of Mech 110. I need to see a couple of seconds video of you just adjusting this and getting a reading from your multimeter. That should just take you a couple of seconds. I want to see a video of that. Okay. That's the first thing you need. That is objective number one. We've just completed. So number two is we're going to try and measure the speed of this motor. Okay. Now this is a Vex 393 motor. So I'm going to write that down. So we have a Vex 393. So I can't show you. I can't show you my screen. I'm just going to load up Google Chrome, and I'm going to type in Vex 393 motor. And the first link is Vex Robotics motor, and it's opening up the spec sheet, which I'm looking at now. Now I have to go down to the very, very bottom, and I'm going to go to Docs and Downloads. And it says, what am I looking for? I'm on page, I can see it says the stall current is 4.8 amps, the free current, don't worry about that. I'm trying to see, does it talk about voltage anywhere? Okay, if I go to outputs, it says all motor specifications are at 7.2 volts. Okay. Now, I wish I knew what the speed is at 7.5 volts. The output speed. Okay. Sorry about this. I'm looking at the two-wire motor 393. And what you have on all of your motors is the standard motor 393 gearing, okay? And it says the output speed is 100 RPM. So at around 7.2 volts, you should get 100 RPM. That's what we want to try and achieve. We want to see, is it actually doing what it's supposed to do? We're going to provide electrical power to the motor. The motor is going to convert that electrical power into mechanical power. Okay? So, I've unplugged my power supply. I'm going to take my multimeter just out of the circuit just for a second. So I'm going to unscrew this and take this apart. Try and go easy. Try and be gentle with those screws. I'm going to take my multimeter and put it away. And I have my motor. I have some copper here. I have the insulator stripped. I'm turning it round. I don't know, I call it a pigtail. I don't know if it is even that. Now look, this is important. If I put the red one in here, I want to really make sure that I don't want to see any copper sticking out. Do you know why? Because that's if I have a big long thing of copper and it sticks out like that, and I have a red one. This isn't plugged in now, so don't worry. If I have something that's like this and I have two long strands of copper, there's a chance that you will twist it or something like that, and then you are going to cause an electrical short. And that's not a good thing. Um, yeah. So please also do not leave this plugged in overnight. Um, Make sure you unplug everything once we're done. So what am I going to do? I'm going to plug this, going to feed this black, and if my copper wire is too long, what I can also do is I can just bend it in half, and I'm shortening it down, and I'm going to feed it in to the minus. See when I say the minus, the negative terminal. Feed it in and tighten it up. I'm having to tighten it up pretty tight, and I'm going to pull on it, and I'm going to do the same on the other side. You're going to have to find some way of recording your the work that you're doing for me. Your cell phone will do the job, but then you're going to have to combine videos together. What do I use to do that? What do I use? Adobe Premiere Rush, but I think you have to pay for that. But it wouldn't be a bad idea if you're learning how to use videos. I use Bandicam to record my screen. Um, you could use Snagit to record your screen, but to put the videos together, um, you're going to have to combine them somehow. We need to talk about that. I'll have to figure that out. Anyway, I have my power supply. I have my power supply connected to my motor, and I'm going to plug it in. Now hold on. First things first. Set this to 7.5. I'm hoping we get 100 RPM. 7.5. Let's plug it in. It's spinning. Now, I'll unplug it. So you're saying to yourself, how the hell are you going to measure the speed of that? In your kits, there are shafts, okay? You're going to feed the square shaft into the square hole. These are shaft colors, okay? This black thing is a set screw. I'm using a 5/64 Allen wrench. And I'm going to tighten this on the shaft like so. Now, I can still pull that out, but what this shaft collar is, it sits sitting above. Now, in your kit, there should be these type of gizmos. Okay, this is called a locking nut, and I can put this on there like so. And if the motor turns, the locking nut turns as well. Let's see if I can do this. Oh, man, I'm having to work today. Okay. Now, um, okay. So number one, you're gonna have to find shafts. If the shaft doesn't fit into the hole that you found, it might be because it has lots of burrs on it. You have to realize the equipment that you're using has been used for probably nearly 10 years now, and it's shown its age. If this thing has rough burrs, or it's mushroomed out, and you cannot seem to get it to fit into the square peg, in your kits there is a file. Now, did I bring mine home? Let me pause this and see if I can find the file. Now, if you're having trouble getting the shaft into the motor, this bad boy is going to be your best friend. It has these teeth, this rough surface roughness, and what you can do is you can take your shaft, and you can always in the same direction. All right, and I don't know if you can see that, but I'm already after taking a bit of that steel off quite easily, just with 2 passes. All right, it's a very, make sure you use the file that doesn't, you want a pretty fine blade. You want a pretty fine blade. You don't want it to be too coarse, and you can if there's any burrs or any mushrooming going on here, or if the end of the shaft is all wonky, the file will tighten it up for you. Okay, and now you should have no problems getting it in there. Okay, now in your tachometer kit there was some of this this flashy tape. Let's open up this tachometer for a second. I know the batteries were included, and I hope you can all you all know how to put in batteries correctly. The reason why this ribbon is here is you can easily take the batteries in and out. So the negative goes with the spring. So that's the negative, right, goes with the spring. So you're going to put them in like so. Hit test. Now let me see. Can you see this? Oh, I like it. Okay, what that is doing is it's emitting a laser, infrared light. And hold on, let me see if I can't multitask. Let me put this lad back on. There we go. And let's get the screw going. Don't drop it on the floor. I don't think I'd be shining this at your eye, to be quite honest with you. Now, what this does is it shines a light out, and what it's trying to do is trying to detect the difference between a black surface and this shiny tape. So what did I just do there? I put the shiny tape on the locking collar, and as this thing spins around, it should catch the shiny tape, reflecting it back, and it's able to measure the speed based on that. Now let's plug this back in. I'm going to hit test. Pretty accurate. I'm getting a little over 110 RPMs. Okay, 110 RPMs. Let's unplug that for a second. Okay, 110 RPMs. Now I'm giving it, what voltage am I giving it? I'm giving it 7.5. Okay, now what we're going to do is we're going to be giving it what voltages? We're going to be giving it 3 volts. We're going to be giving it 4.5 volts, 5 volts, 6 volts, 7.5 volts, 9 volts, and 12 volts. And what do you think is going to happen? The more voltage I put into this, what do you think is going to happen to the speed? It's going to increase. Okay, so that's your first thing. First thing you need to know, there is a relationship between voltage and speed, and it is proportional. Is that true? Yeah, it is proportional, all right? If I say it is voltage and speed. Okay. Now, so let's try this. I'm going to crank this down to 3 volts. So this is moving very, very slowly. Whenever something is moving that slowly, we might have to do another trick to get to measure the speed. But let's see. I should be getting, let's try this. 1,000, 2,000, 3,000, 4,000. This is going to be around 40 RPMs. It should be around 40 RPMs. So I'm getting 47. Now, what I've done in the past is I will put 2 of these on, like so, and I just divide the number by 2, okay, and you'll get a better reading. So let's try that. What am I doing? I'm holding it with my hands and I'm shining this on the tape, trying to get it as perpendicular as possible. So I'm going to divide that by 2, that number divided by 2, and I'm going to get 45 RPMs. Okay, let's crank it up to 4.5. How am I doing that? I'm using my little key. Plug it in. Let's say 140 RPM. We're going to have to divide that number by 2, so it's 70 RPM. I would probably go with the configuration with both of the shiny tapes on it. Alright. Now, let's go back to the power supply and let's bring it up to 6. Let's go and make it 5 volts, whatever. It's not exactly a big jump, but anyway. Hundred and 60 divided by 2 is 80 RPM. Alright, we'll bring it up to 6 volts. you can hear the pitch of the motor increasing. So let's say 190. What the hell is that? 85 RPM. We crank this up to 7.5. Now I'm getting 230 RPM. What is that? 230 is 115 RPM. I'm having to divide it by 2. 230, 115. Okay, let's bring it. Let's bring it to 9 volts. Look at the speed of it now. We'll go 280 to make the math easier. 280 is 140 RPM. And then the last one is 12 volts. Now I'm making sure these guys are not going to touch each other. That's really spinning. Let's say 360. 360 is 180. 180 RPM, maybe 182, but 180. Okay. So you can see how the voltage increases, the speed is increased now. Let us, I'll pause this for a second and I'll see if we can plot this somehow. And we can see, learn to see if we can plot a graph. So if you go to, if I type in, what the hell, XY graph in Google, don't worry, you don't need an expensive program like Excel. We can find a free one. If you go all the way down to rapid tables, okay, and we're going to call this voltage versus speed, and then it's a series data values x1, y1, x2, y2, and so on, right? So I'm going to go 3 is x1, and at 3 what were we getting? 45 volts. 4.5 volts, what were we getting? 70 RPM. At 5 volts we were getting 80 RPM. At 6 volts we were getting 85. 7.5, 115. 9 we were getting 140 RPM, and at 12 we were getting 180. And I'm going to go draw. Look at that, straight line. Look at that. H label, horizontal H label. What are we going to call this? Volts, RPMs. Oh, look at that. And that's where we are. That's what we need. That's what you need to give me. Okay. I need a quick video of you connecting the DC. I need a video of you measuring measuring voltage using your digital multimeter. I need a video of you measuring the speed using the tachometer. I need a video of you showing me this, and you can draw this if you want to. Draw it on a paper if that's easier. Plotting it out old school. I'm going to pause this for a second. I need to find out a way how you can stitch videos together for free. Do you have Windows Movie Maker on here? Let's have a look. Windows Movie Maker. Can you stitch videos together using combine videos? See how you do. Look, I only use ones that I have paid for. I don't know the free ones. Um, you can use the Windows Photo to combine, but you only want video just with lab number one, with those three things that we discussed: the connecting the motor to measuring the power supply using the multimeter, number one; number two, measuring the speed of a DC motor; and then number three is plotting a curve of voltage versus the motor speed. What are we going to work on next in the next lab? What are we going to work on? We're going to learn how to use different types of switches. We're going to single pole, single throw, double pole, double throw, different types of switches like that. And then we're going to somehow measure the current versus the torque. So look, hopefully this has been too confusing, and I will see you all on Wednesday.